Today on Macaulay Math, we're graphing the other four trig functions. Intro. Okay, good day. I'm Professor Macaulay. This is Math 150 Pre-Calculus, Lesson 21 on graphing all trig functions. Our goals for today. We're going to sketch the graph of the tangent function. We're going to sketch the graph of the cotangent function. We're going to sketch translations of secant and cosecant functions, and we're going to sketch translations of damped trigonometric functions. This lesson adds the graphs of the other four trig functions. Since these functions are defined by ratios, there are going to be divisions by zero. Therefore, keep in mind that the graphs of tangent, cotangent, cosecant, and secant all have vertical asymptotes. Other than that, we will try to keep the rules for graphing consistent with the previous lesson to keep the amount of information that you have to memorize at a minimum. Let's get started.
Okay, so we're still graphing trigonometric functions. This lesson, though, we'll be adding the other four trig functions. And what I mean by that, secant, cosecant, tangent, and cotangent. The difference between what we did in lesson 20 and what we're doing here in 21, the graphs of tangent, cotangent, cosecant, and secant all have vertical asymptotes. Since these functions are defined by ratios, there are possible divisions by zero. I pulled this off of the trig identity cheat sheet. Cosecant is defined as 1 over sine. Secant is 1 over cosine. Tangent can be defined as sine over cosine, and cotangent can be defined as cosine over sine. We know from the unit circle that the value of sine and cosine on the unit circle can both be 0. And whenever you have a division by 0 that cannot be reduced, you are going to have a vertical asymptote. And so the biggest difference between what we did in the last lesson and here is that you are going to have to find some vertical asymptotes, and that's going to happen where you have divisions by 0. Now, the method for graphing does not change. We're still going to use the same steps that we used in the last lesson. There are a couple of differences, but we're going to try and keep it as consistent as possible. So we're going to find the amplitude. First note, tangent and cotangent do not have amplitudes. We're going to find our period, and then we're going to make our quarter turn divisions. Another note, tangent and cotangent's period is just pi units. But I don't want to make you remember another thing, so we are going to treat tangent and cotangent the same way that we treat the other four trig functions. If the c value in bx minus c is equal to 0, we graph the first two periods starting at the origin. If the bx minus c value has a c something other than 0, then we're going to set bx minus c equal to 0 and bx minus c equal to 2 pi and solve those for x. They're going to be the endpoints of your first period. We're going to plug in points along the curve, and then we're going to draw a curve. The list of the remaining trigonometric parent functions and the transformations, cosecant, secant, tangent, and cotangent. These are the transformed values. And again, for secant and cosecant, A is going to be, and I'm putting this in air quotes, you can't see it because you can't see my fingers, but A is the amplitude. Tangent and cotangent doesn't have an amplitude. This B value changes the period. C is a left and right transformation that works in conjunction with B if it's something other than 1. And then this D value is your up-down shift. All right, let's start with an easy one. We are going to start with just tangent x. Remember, tangent has no amplitude, and so we're going to find the period and make our quarter turn divisions. We're going to treat tangent the same way we did sine and cosine in the last lesson, even though we know that the period of tangent is just 2 pi. So we're still going to treat it as if it has a period of 2 pi. And so I'll put my first period there, my second period there. There's no left-right shifts. And we're doing this simple one just to start seeing how we can think about plugging in those asymptotes. So I have my 2 pi here, and I have my 4 pi here. And then we'll divide from 0 along the x-axis and the y-axis. we'll divide from 0 to 2 pi in half. That will be just pi. We'll divide those two segments into halves as well. From 0 to pi, halfway will be pi over 2. Then I will cut the second period into quarters as well. We are now counting by pi over 2. So I've got 1 pi over 2, 2 pi over 2, 3 pi over 2, 4 pi over 2 reduces down to 2, 5 pi over 2, 6 pi over 2 reduces down to 3 pi, and 7 pi over 2 does not reduce. 8 pi over 2 is 4 pi. All right. So remember from that quotient identities, tangent is sine over cosine. I'm going to put this right here. I'm going to make this the sine of x over the cosine of x. And we're going to start at this point right here. And if you remember, this point is 1 comma 0. And at 1 comma 0, when the angle measure is 0, the sine is 0, the cosine is 1. So I have 0 over 1, that is going to be 0. That is my first point. Now, when I get to this point right here, that value on the unit circle is 0, 1. So when the angle measure is pi over 2, right here, I get 1 over 0. Now that is undefined. And since it's undefined, I have a vertical asymptote here at pi over 2. Now when I draw this curve, I have two options. There's no other value between 0 and pi over 2 where I have this tangent function equaling to 0. So it can either start here at the origin and go up, or it can start here at the origin and go down. Now the way I make that decision, by looking at what's going on here. My angle measure starts at 0 and it moves up to pi over 2. All of these x values in this quadrant will have a positive x value and they'll have a positive y value. And so positive divided by a positive will always be positive. Therefore, this graph has to go up. Now, here at pi over 2, I still have the undefined. But now I am moving towards this point right here, which is the point -1, 0. And so when theta is pi units, I now have 0 over -1. So 0 divided by -1 is another 0. And so I have to decide what is going to happen from this vertical asymptote till I get to pi. There are only two options. It can either come from positive infinity down to 0, or it can start down at negative infinity and move up to 0. Again, I look at what's going on in the unit circle to make that decision. I am moving from this point to this point, and it encompasses all of the ratios of the y's to x's along this value. And in this second quadrant, the x values are negative and the y values are positive. So when I go positive divided by a negative, I get a negative. That tells me that all of the values for tangent from pi over 2 to pi must be negative, and it goes like this. Let's do one more. I am now moving to this point right here. The coordinates of this point is a 0, -1. Now, if I go back up to this definition of tangent here, sine over cosine, I will get -1 over 0. That is a division by 0, so at 3 pi over 2, I am going to have another vertical asymptote. And so again, I have two options. It can either start at the 0 and go up, or it can start at the 0 and go down. We are encompassing all of the values, y over x, in this third quadrant. Now, in this third quadrant, both the x value is negative and the y value is negative. So if I have a negative divided by a negative, I have a positive. So at pi to 3 pi over 2, all of the values in tangent must be positive. Now, we can see that it's starting to repeat. Therefore, if I do vertical asymptotes on every other value, I should be able to draw in this expression like this. And there is our graph. Now, if you want, we can check it in Desmos. So let's go to Desmos real quick. And let's set up our graph to make it look a little closer to what we had. And let's go from negative pi over 2 to 5 pi. And then let's make the step pi over 2. And there we can see it. And then make sure we are in radians. And we'll just go f of x is equal to tangent of x. And we can see that our graph looks very similar. Now, I said there was no amplitude on tangent and cotangent, but just to show you what that a value does out front, I'm going to put an a in here. And I'm going to put a slider there. And so when I grab this slider and a gets bigger, you'll see that it looks like it's stretching out. So remember, amplitude is a stand-in for the vertical stretch. And then the closer that a gets to 0, the flatter is the best way that I'm going to make it. And it gets to, when you get closer to those zeros in tangent, it's going to be a little bit flatter. Okay, next example. We are graphing y equals 2 secant 4x plus 2. And again, we are not going to be changing our method at all. We'll go through the same steps that we did in lesson 20, and we'll start with the amplitude. That is going to be absolute value of 2. And just to refresh, I'm referring to this 2 right here, not that one. And so the absolute value of 2 is 2. And then my period will be 2 pi divided by the b value, which in this case 2 pi over 4. When I reduce 2 over 4, I get pi over 2. So my period is just going to be pi over 2. That's kind of small, but that's okay. And I have no c value, so I have no left-right shift. But this 2 here says that I translate up 2 units. So I am going to put that quote-unquote center line. I'm going to move that up to 2 on my y and my x axis. And since the amplitude is 2, it's going to go up 2 more units. I'll put a 4 there. It's going to go down 2 units. And so I'll put a 0 there. Now I have my period as pi over 2. So I will make 2 periods. The first one will be pi over 2. The second one will just be pi, because pi over 2 plus pi over 2 will be just pi. Let's make our quarter turn marks. And we'll do it on both of them. And so halfway between pi over 2 and 0 is pi over 4. Halfway between 0 and pi over 4 is pi over 8. And so we're counting by pi over 8. So I have 1 pi over 8. 2 pi over 8 is pi over 4. 3 pi over 8 does not reduce. 4 pi over 8 reduces to pi over 2. 5 pi over 8 does not reduce. 6 pi over 8 reduces to 3 pi over 4. 7 pi over 8 does not reduce. And then 8 pi over 8 reduces down to pi. Now I need to move this down a little bit so that we can see it. And this one's going to be a little bit different. Remember, we're doing 2 times the secant of 4x plus 2. Now, because of those reciprocal identities that I have up here for secant being 1 over cosine, I am going to rewrite this just for me so that I can see it. It's going to be 2 times 1 over cosine of 4x, and then I'll have a plus 2 on the outside. That's just going to help me find those asymptotes a little bit easier. All right, we start at 0. When I plug in 0, 0 times 4 is 0. The cosine of 0 is 1. 1 over 1 is 1. 1 times 2 is 2. Plus 2 is 4. So at 1, I have 4. Now, pi over 8. When I plug in pi over 8 times 4 is pi over 2. That's good because that's one of those quarter turns on the unit circle. The cosine of pi over 2 is 0. So I have 1 divided by 0. That's an undefined regardless of these two values out here. Therefore, at pi over 8, I have a vertical asymptote. So the graph can do two separate things. It could start here and go down, or it could start here and go up. Those are your two choices. Now, I can tell you right off the bat that it's going to start here and go up, and the reason that I know that is because this is a fraction, and the only way a fraction can be 0 is if the numerator is 0. And so I would need some way to make this thing equal to 0 so that it could start up here and eventually cross the x-axis. In fact, secant and cosecant never actually cross the x-axis without some kind of up-down shift. More proof, if we make a little unit circle like we did on the last one, from 0 to pi over 8, I am in this first quadrant, and cosine is always positive in that first quadrant, so this graph is going to go up. All right, now pi over 4. Pi over 4 times 4 is just pi. The cosine of pi is -1. 1 divided by -1 is -1. Times 2 is -2. Plus 2 is 0. So at pi over 4, I have a 0. The graph from pi over 8 to pi over 4 could do two things. It could start at infinity and come down to 0. It could start at -infinity and come up to 0. The reason that we know that it has to come up is because in this second quadrant, cosine is always negative. So I get a value that starts down here and comes up. 3 pi over 8. 3 pi over 8 times 4 is 3 pi over 2. The cosine of 3 pi over 2 is 0. 1 divided by 0 is undefined. So at 3 pi over 8, I get another vertical asymptote. The function can do two things from pi over 4 to 3 pi over 8. It can either start here and go up, or it can start here and go down towards -infinity. Now, because we are still in that third quadrant, cosine is negative here, so I'm going to have negative values. It's going to continue to go down. So my last value in this first period is pi over 2. Pi over 2 times 4 is 2 pi. The cosine of 2 pi is 1. 1 times 2 is 2. Plus 2 is 4. So at pi over 2, I'm going to have another 4. Hopefully you can see the pattern that it's going to come down, because in that fourth quadrant, the x values are positive. And now I see a pattern. And so I will plug in, let me erase that. I will plug in every other, I'll have that vertical asymptote. So we will draw up there, and then at 3 pi over 4, it'll go down. And then from 7 pi over 8, we'll have another 4. All right, let's quickly check in Desmos. So I'll go over to Desmos. We'll change my x-axis to only go to 2 pi, and we'll change the step to go to pi over 8, and then we will come back over here and we will change this graph to 2 secant 4x plus 2. And if I pull down here, we can see that we have 0, 4, we have pi over 4, 0, we have pi over 2, 4, we have 3 pi over 4, 0, and we have pi 4. And if we go back here, pi and 4, at 0 we have 4, and at pi over 4 we have 0. So I feel very confident in that graph. Next, graph the trig function. 1/2 cosecant 2x minus pi. So now we're going to have some left-right shifts because our c value is something other than 0. But I'm still going to go through the same process. I will start by saying that the amplitude is the absolute value of 1/2. So that's 1/2. And then to calculate the period, we're going to go 2 pi divided by 2. That'll give me just pi. And there's no up-down shift, so I don't have to worry about that. But then I can say that this x-axis is my center line, and the extreme values will be 1/2 and -1/2. And then to find the starting points of the first period, what we'll do is we'll take what's inside the parentheses, and remember, we'll set it equal to our standard endpoints of a trig function, both 0 and 2 pi. So 2x minus pi is equal to 2 pi. And so I'll add pi to both sides. That'll give me 2x is equal to pi. And for this one, it'll be 2x is equal to 3 pi. And then if I divide both sides by 2, I have x equaling to pi over 2 and x equaling to 3 pi over 2. So if I go 3 pi over 2 minus pi over 2, I'll get 2 pi over 2, which is pi. And since we found that the period is just pi, I feel very confident in that. And so I will make my first period from pi over 2 to 3 pi over 2. And then if I add another pi to that, I'll have 5 pi over 2. And so I'll make some quarters in both of these. And so halfway from pi over 2 to 3 pi over 2 is going to be pi. And then halfway between pi over 2 to pi will be 3 pi over 4. And so from pi over 2 to 3 pi over 4, that's pi over 4. So I got 2 pi over 4, 3 pi over 4. 4 pi over 4 is pi. 5 pi over 4 doesn't reduce. 6 pi over 4 reduces to 3 pi over 2. 7 pi over 4 does not reduce. 8 pi over 4 is just 2 pi. 9 pi over 4 doesn't reduce. And 10 pi over 4 reduces to 5 pi over 2, which makes me feel confident that I've done this correctly. So again, I'm going to come back up to this original equation, and I'm going to rewrite it here as y equaling to 1/2 times 1 over the sine of 2x minus pi, and we will use that as our expression that we'll plug these numbers along the x-axis into. So let's get started. Pi over 2 times 2 is pi, minus pi is 0. The sine of 0 is 0. So I have an undefined. So right off the bat on this problem, I end up with a vertical asymptote. 3 pi over 4. 3 pi over 4 times 2 is 3 pi over 2 minus pi is pi over 2. That's good. The sine of pi over 2 is 1. I get 1 over 1, which is 1, times 1/2 is 1/2. And so I have that value there. Hopefully, based on the last problem, you can remember that it doesn't cross your axis. This thing is going to go up, and I know that because in the first quadrant, from here to here, your sign values are all positive. Now if I plug in pi, pi times 2 is 2 pi. 2 pi minus pi is pi. The sign of pi is 0. I have another vertical asymptote. And again, in the second quadrant, all of your y values are positive, so I have to stay positive. 5 pi over 4. 5 pi over 4 times 2 is 5 pi over 2. Minus pi is 3 pi over 2. So I'm going from here to here. The sign of 3 pi over 2 is negative 1. 1 over negative 1 is negative 1 times a half is negative a half. So I have that point there. And again, hopefully from the last example, you can see that from here to here, the y values will all be negative. 3 pi over 2 times 2 is 3 pi, minus pi is 2 pi. The sign of 2 pi is 0. So I have another undefined. But in that fourth quadrant, the sign values are still all negative. So I draw down like that. I have my pattern. So I can, every other value on the x-axis, I'm going to have my vertical asymptote. This next one will be at half for 7 pi over 4, and it will go up. And then at 9 pi over 4, I'll be at a negative a half, and it will go down. And so just to make sure that we're checking it, let's go over there to Desmos, and let's make this a little bit smaller. Let's make it from negative pi over 4 to pi over 4. And then let's change this to 1 over 2 cosecant, and then it was 2x minus pi, close those parentheses, and we started at pi over 2. We had our vertical asymptote at 3 pi over 4. We had a half. At 5 pi over 4, we had negative a half. And 7 pi over 4, we had positive a half. And then at pi over 2, pi, 3 pi over 2, and 2 pi, we had vertical asymptotes. So did very well with that one. All right, last example is a damped trigonometric function. Now we're not going to spend a bunch of time on this, but when two functions are multiplied, the result has properties of both functions. In this case, the function y equals x is the dampening function. And so when you think about graphing this, you want to think about graphing these in two parts. And if you recall the sine function, it has extreme values. So it goes from positive 1 down to negative 1. And so every value here, you can think of it as a percentage. And when you multiply it times another function, it is a percentage of that function. At positive 1, you have positive 100%. And at negative 1, you have negative 100%. And so the way that you come across when you go to draw these things, what we'll do is we'll graph the line y equals x for positive 100% and y equals negative x for the negative 100%. And those graphs, they look like this. Now, if we remember the sine graph, it has quarter turns at every value of pi over 2. So I'll have pi over 2 here. I'll have pi. I'll have 3 pi over 2. I'll have 2 pi. And then I'll have 5 pi over 2. Okay. I know that when x is 0, I get 0. When x is 0, sine is also 0. So I get 0 times 0. My first point on this graph is 0. All right? At pi over 2. At pi over 2, When x is pi over 2, I get pi over 2. The sine of pi over 2 is 1. 1 times pi over 2 is pi over 2. So this point, this red point, is at pi over 2, pi over 2. Then when x is pi, I get pi. The sine of pi is 0. 0 times pi is 0. So at this point, I'll be back down to 0. And then 3 pi over 2. When I plug 3 pi over 2 in for x, I get 3 pi over 2. The sine of 3 pi over 2 is -1. So -1 times 3 pi over 2 will give me a point down here where that point right there is -3 pi over 2. And then at 2 pi times the sine of 2 pi is pi times 0. So I'll get another 0 here. And then at 5 pi over 2, the sine of 5 pi over 2 is the same as pi over 2. So I'll have a 1. And so at this point, I'll have that value there, which is 5 pi over 2. So I'm going to get a graph that looks like this. It's going to grow. And then on the other side, I'm at negative pi over 2, pi, -3 pi over 2, and then -2 pi. In this case, the sine of negative pi over 2 is -1. And so at negative pi over 2 times -1 will be +1. So I'll get a point here. And then at negative pi times 0 will be 0. And then -3 pi over 2 is +1. -3 pi over 2 times +1 will give me -3 pi over 2. So I'm going to get a graph that looks very similar to the other one. Just my graph is a little off. But we can check that at Desmos. Let's do that. So let's go to Desmos by putting an X out front of here. And let me move this. And let's zoom out just a little bit. Let's go on the y-axis from -10 to positive 10. I need a 0, negative 10 there to positive 10. Let's close this, and then let's put in y equals x and y equals -x. Let's zoom out just a little bit further. Let's go, let's say -20 to positive 20. And then let's make our x's a little bit bigger. Maybe from -10 to positive 10. We can see that my graph is pretty darn close. Okay, that's all I got for today, folks. So, Star Wars fun fact of the day. Donnie Yen, a famous Chinese martial artist, plays Chirrut Imwe, a guardian of the wills. Donnie suggested to the director that they make his character blind, as it would add another layer of depth to the story. And in your favorite math teacher's opinion, Rogue One is the best Star Wars movie since Disney took over. Well, that's all I got for today, folks. Have a great day. Goodbye.